Let's do 5 simultaneous equations together. Now, I know it says 10 there at the top, but we actually are only doing 5 because the video is getting quite long. Anyway, we're doing 1 linear and 1 quadratic versions of this type of question. This is suitable for Leaving Cert ordinary level and higher level students, so make sure you work along with me on this. Pause, rewind, whatever you need to do, work with me on this one. So this method requires 4 separate steps. So the first step is you take the linear equation and you rearrange it where one of the variables is isolated. One variable will be more convenient to do than the other. You're going to sub into the quadratic equation using that rearranged linear equation. You're going to solve for the first variable. You're going to take that information, sub it back into the linear equation and find the second set of variables. Let's go through an example. So in question 1 here, we have x squared plus y squared equals 25 and x minus y plus 1 equals 0. And you can see there I labelled the linear and the quadratic equation, and I rearranged the linear equation where x is isolated. So I moved the minus y and the plus 1 over to the right hand side. Then instead of x squared in my quadratic, I replaced it with minus 1 plus y. And what this actually does here is it creates a situation where I have just one thing I don't know, which is the y variable, and lots of numbers. Now there's plenty of multiplying out to be done here, as you can see me working away. But what will happen is when we get to the end there, we end up with a nice simplified quadratic with the variable y. We factorize it or use the minus b formula there, and we find that y is equal to minus 3 and y is equal to 4. We use that information back into the linear equation, which is x equals minus 1 plus y. And I sub in the two y values, the minus 3 and the 4. And I get my answers. And I pop them into little coordinate points to keep them nice and tidy. Looking at the second example, we're pretty much following those 4 steps again. So we look at both of the equations we've been given and we identify which one's linear. And we take that and we rearrange it. And in this case, I'm going to let x be on its own. So I'm going to move that minus 2y over to the right hand side. And I get x is equal to 12 plus 2y. I'm going to use that 12 plus 2y to replace any x in the quadratic equation. So you can see now there is a lot of multiplying out being done here. So I highly recommend you grab a pen, you grab a paper, and you multiply this out with me. It is quite often a possibility that there will be errors with your multiplying out or with your signs and things like that. It's really important to be as clinical as possible here. So make sure you're working with me and pause it if I'm going a bit too fast. When we multiply all these things out, and again, I'm showing you every single step here, we end up simplifying it down to a quadratic, and we end up getting 5y squared plus 24y plus 28 equals 0. And I am not touching that with factorizing. There is absolutely no need. I'm going to use my minus b formula here. That is found in the algebra section in your log tables. And I identify A, B and C there as 5, 24 and 28. And I pop it into my minus b formula. Again, careful to make sure that everything is in the right place. I find my two values for y, which is minus 2 and minus 14 over 5. Again, in step 3 of my method, I am going to take that information, step 4, and I'm going to take that information, I'm going to sub it into the linear equation from above. I always use the rearranged one because it always works out nice. X equals 12 plus 2y, I sub in my minus 2 and I sub in minus 14 over 5 and I get my matching y values. Again, I always write them as a coordinate point or as a couple because it reflects what's happening if we were to graph this. Moving on to question 3, it's same kind of situation again. I'm identifying my linear and my quadratic and I'm rearranging my linear equation there, as you can see. So what I'm going to do is I'm going to replace every y in that quadratic with minus 7 plus 2x. And I multiply it out. You cannot get away from plenty of multiplying in these questions. It is inevitable. So when I multiply all that out, I end up getting 5x squared minus 28x equals 0, which is not your traditional trinomial. So I think to myself, do I have other options in terms of solving, factorizing quadratics in that form? Yes, I do. And in this case, I use highest common factor. So I notice that there's an x in both terms. So I basically factorize that out. And I end up getting that x is equal to 0 and x is equal to 28 over 5. Again, last step of my process, I take those two x values, I sub them into the rearranged linear equation from above, and I find that I get the points 0 minus 7 and 28 over 5, 21 over 5. So I have a challenge for you. I think you should do this question all on your own. So question 4. So I think you need to pause it right about now and give this question a go yourself. I hope you give that one a good go. Well done. Again, it's important to test yourself and figure out what you don't know. A lot of math students, regardless of ability, regardless of level, whether you're ordinary level or higher level leaving cert, a lot of those students don't know what they don't know. That sounds like a bit of a tongue twister, but it really is true. So I hope if this was difficult for you, you are going through the solution with me here and you are finding a way through it. And if you did do it perfectly correct, well done. So I've got down to the last step here where I've found my x values. I'm subbing back into the linear there and I'm looking for my matching y values. It is perfectly acceptable to get a negative number and to get some fractions. As long as you're confident in your work, there should be no issue with these numbers. Let's look at our last and final question this evening. We're going to be moving on to question 5 shortly. Again, if you want to pause the video, that would be a great idea and you can have a go at this question yourself. So you could pause it right now. And I hope you give it a go. So again, we're going through the process. We are rearranging our linear equation there where x is equal to minus 13 plus 5y. And we are subbing that in for any x that we find in that quadratic. So again, lots of multiplying out, lots of working. Just be careful and clinical and do it one step at a time and you'll be perfectly fine. We work our way down through that. And while you can see me doing that, I want to remind you of something. Simultaneous equations come up as an algebra question, but they're also relevant in the likes of coordinate geometry of the line and the circle, especially these types, and also in functions where you've got linear functions and quadratic functions. So actually they are a very useful skill to have and you will see them in several places throughout the course. Now that we're moving down through this question, we see that we're solving for y and we get y is equal to 2 and y is equal to 3 there. And we go to our last step where we sub back in and we find the matching x values there. Make sure that you are subscribed to my channel here because I am continuously uploading twice a week to make sure you have all the maths resources you could possibly need for free. See you in the next one.